We on the air?
Yep.
So the other day, we did a video on the little Jeep F-head 134 engine, kind of start to finish on that. And I noticed in the comments from one of the viewers had mentioned that he wished we would do an 8N Ford tractor engine because he was getting ready to do one of those and was just wondering what they would be like. They're a L-head block, flathead type. Just like what this one here is. This is a Ford 239 V8 flathead engine. These were manufactured from, I think, 1949 to 53, and they have a little bit unusual type valve guide in there. We'll go into that in a little more detail later. We're going to go ahead and get a little video here of the valve work on this. I've already bored the cylinders and surfaced the block. Nothing unusual there, no different than any other V8 engine, so I didn't take the time to film that. But after having that comment from the viewer, I thought let's go ahead and show some of the valve work on this. And again, this side here I have already completed. I have new valve seats in there and all finished, ready for the valves to go in. But this side here, I have not done anything to the valves yet. So we'll show in this video, we'll show setting this up on our machine and what it takes to do the machine work on one of this style. Maybe I better start here with showing some of the parts that go into the valve train. This being a flathead engine, does not have any rocker arms, no push rods, anything like that. The camshaft is right down the middle of the block, like most any overhead valve V8 engine. The lifters ride right on the camshaft, just like any other engine, but instead of having push rods or rocker arms, when the valve goes in, the lifter contacts right on the end of the valve to push the valves open. And I don't have all those parts here to show you, again, because this is just a partial job. We're just doing some of the machine work here. But at least as far as the valves here, let me show you. You have a very typical looking valve, but then this is the valve guide that goes in. And when you assemble these, you, of course, lube up the valve, slip it into the valve guide. In this large groove here on the intake side, there's a big square cut O-ring that goes in there to seal the valve guide so it doesn't suck oil past the outside of the valve guide. There is no seal to keep oil from coming up the valve stem itself. That's just not an issue on a flathead type engine. I mean, gravity keeps the oil down where it needs to be, but they do have to have a seal around here to keep from pulling vacuum and oil up out of the crankcase there. This is not the correct spring, but it's close to what the spring would look like, so I'm going to use that for an example here. You put the spring on next, you put the retainer on, you slip your valve keepers in, or the valve spring retainer keepers in, and the assembly goes together like that. Then you drop it down in the engine here. Yeah, it won't go in, my spring's too large, I can't show that. But anyway, you drop that down in, and there is a tool. I don't have one, but back in the day when these were popular, there was a tool that you got in there and you would pull this valve guide down, and then this clip goes in, that groove in the guide there, so that with the spring pressure and everything, it pulls this valve down against the valve seat, but it also holds the valve guide in place where it needs to be. So they are a little unusual in that respect.
You know, we stay pretty busy here in the machine shop with these old engines, and things have only gotten busier for me and my family since I became a girl dad a few months ago. I know a lot of you are parents, so I'm sure that you understand the feeling of wanting to give your kids a head start on their financial future, but investing is both confusing and time-consuming, so we've partnered with Fabric by Gerber Life to make it easy for you to set up an investment account for your child that grows with them and helps prepare for their financial future. Fabric by Gerber Life was designed by parents for parents to make it easy to plan for and manage your family's financial path. With a kid's investment account from Fabric, you can start investing in your child's future today. Your kids can't invest while they're minors, but a UGMA investment account allows you to invest on their behalf and give their investments more time to grow. It's all online, so you can set up an account in just 5 minutes with as little as $1 a day. Invested funds can be used for education plus so much more, like summer camps, band equipment, or club sports. Something else that I love about it is that when they're adults, they can even use the funds for their first home or to start a business. There are no contribution limits, multiple tax advantages, and they're SIPC insured up to $500,000, plus no commission fees, just a low, flat monthly maintenance fee. It's also easy to get your family and friends involved in your child's future by sharing your child's unique gifting link. I've challenged my family to invest in my daughter's future by matching every dollar that they spend on toys she will outgrow with a gift to her account. Fabric has partnered with Gerber Life, a name trusted by millions of families like yours for over 50 years. Join the thousands of parents who trust Fabric to help protect their family. Start investing in your child today at meetfabric.com/JimsAuto. That's meetfabric.com/JimsAuto. MEET fabric.com/JimsAuto.
None of our modern equipment here is designed for this type of an engine. Everything we have here, even this old TCM machine that I've had for the last 40 years, was never designed to work on a Flathead V8 engine. The last time we did one of these, I did figure out some of my tooling and stuff and was able to do the valves and seats on here, but it's a little bit cumbersome to get done that way. So this time I have the 30, and I figured out that if I use a combination of this rollover fixture from our boring machine and these V-block fixture that we normally use when we're balancing crankshafts, and kind of a combination of some of the tooling from the 30, I can get this mounted in here to do the work on it. Now this engine has valve seat inserts in it from the factory, and I honestly do not know if they are of the proper material to where they would stand up to unleaded gas or not. A lot of times these older engines, anything that was for any heavy duty use, did have harder seats in them from the factory, even when there was still lead in the gasoline. So again, this one has all the seats put in it from factory. I don't know if they would survive or not. Some of them are kind of pitted, so we've just opted, we're going to go ahead and pull those all out, put all new seats in. Customer in fact requested that I do that, otherwise I might have tried to use these. But he requested that we put all new seats in it. And something else on these engines that shows up when you're working on them, depending where you look, the best information I could find, the center line of the cylinders are not directly over top of the crankshaft. They are offset to one side by about 3/16 of an inch. When I start working on this block, that shows up. One of the first things you notice, if I look at the distance here from this top row of head bolts to the top edge where the manifold bolts on, see that distance there? We've got, what, maybe 3/8 of an inch or just a little bit better, eyeballing that. And I go around to the other side and look how much wider that is. And that is because of the cylinders being offset. The cylinder on this side is offset this direction. This cylinder then in turn is offset down this direction, and that changes the distance here of where the head bolt goes through in relationship to the top edge of the block. The next thing that I've always noticed on these, on this bank, if I look at that top edge of the valve seat here, it is actually recessed down in oh, I'm guessing 30 or 40 thousandths from the deck surface. But if I come around on this side, you'll see that when I surfaced this block, it actually touched the top edge of that valve seat. And that has to do with the geometry of these cylinders being offset and valves and everything else offset. Things are just a little different from side to side. They're not quite symmetrical like you would expect a V8 engine to be. And again, the valve guides here are not perpendicular to the deck surface. They are actually laid over. I'm exaggerating that a little bit, but they are laid over this direction, and the ones on this side are laid over towards the downside of the engine. But when you start putting this all those different angles and geometry of that together, it makes a very obvious difference on the way the valve seats look in relationship to the deck surface of the block. And I know somebody's going to say, well, no, you've decked the block wrong and one side is taller than the other. No, that's not the case. When I set this block up, this block is actually probably the nicest old 239 I've ever worked on. I'm quite impressed with how nice it is yet. But the deck surfaces were pretty square on it when I started on it, and once I got done in our machine, I would say if you used to come back and measure this, I would be surprised if I was off 1, maybe 2 thousandths max of being equal distance from the crankshaft on each side and front to back. So with that being said, let me go ahead and get this over into the machine and mount it up, and we'll see if we can get started on it. So I've got the block mounted up here on the Surdy now, ready to start doing the valve seat work. And again, I used a combination of the machine itself, plus some V-blocks, plus this bar that belongs in the rollover fixture on our boring machine. Little bracket here on the front clamped to the other deck surface so that once I level this up, I can have it clamped down in place. It's actually broken, but it's an old pilot from our Sioux hard seat grinding equipment. That this would have been the latest technology in 1950, between 49 and 53 when this thing was built. But anyway, it goes down in where the valve guide would go. See, normally when we're doing valve work, you put a pilot down inside the valve guide. But on this engine, because of the way it's designed, you have to put a pilot down in where the valve guide goes. So this does have just a little bit of a taper, wedges down in there. And in my case, what I need that for is to get this block level to the machine, because I want my valve guide as much perpendicular, straight up and down as I can possibly get it. Doesn't have to be perfect because the machine does compensate quite a bit for that, but I put that old style pilot in there, I put my level on here, and you can see I'm off just a little bit one end to the other, but it's well within reason of what the Surdy itself will compensate for. So I'm happy with the way I have the block mounted and leveled here. But now I'm going to have to go in and cut these valve seats out. Sometimes I will put a freeze plug inside the valve seat just to block the weld from going down in the port, and then run a bead around there, pop the seats out. But looking at the material these are made out of, I'm not sure how well they will or won't weld. So I've decided I'm just going to go ahead and cut them out. And to do that, I will set up one of my Surdy seat cutters here, and we'll go down in, and I'm actually going to do this in 2 steps. I'm going to make cut, take about half the seat out, and then I'll come back, take another cut to where I'm within just a few thousandths of the actual counterbore size. Probably take my pocket knife, because it seems to work well to break those edges. I'll just take my pocket knife and I should be able to pop the edge of that seat, whatever is left, peel it out of there, Then we will come back with the seat pocket cutter. I'll go in with this one and we'll cut this for the next oversized valve seat. Whoops, there it went. Dropped it out the bottom. Don't let Nicholas know, you're not supposed to drop these, it chips them sometimes. Once I get those out, we'll put the new seats in. Then I'll come back again with the 3-angle cutter and we will finish our valve seats the way they need to be for the valve to seal. So let me get the cutter set up here for the first cut and we'll get started. Lock that in the machine. And then the valve guides are just a slip fit into the block. In fact, I wish they fit a whole lot closer than what they do. Because when I have one of the old style Sioux pilots wedged into that valve guide, wedged in there tight, and I put that guide in place in the block, you can see this. I've got quite a little movement there, and the Surrey does not like sloppy pilots like that. I'm just kind of amazed that these engines ran as well as they did, because there was just never a good way to do a quality valve job on these back in the day. I mean, you could get the job done, but the standard was nowhere close to what we have now. So to help compensate for that, I've taken one of the valve guides and I've actually run a knurler around the outside of it and then polished the outside down again to where it's a lot closer fit into the block. I actually have to kind of push those to get them down in. So I'm going to shove that one down in where it needs to be to sit correctly. I might need a little stick here to persuade that just a little. Whoops, I shoved it right on through once it got where it wanted to be. Okay. And then to keep that from falling through, I'm going to do something really high tech. This is called a wooden tubifor, special tool. I'm going to slip that in here. Let's see, this is a little different than the other side was. May not fit quite as well. There we go. Now I got it in place. Slip that in right there. If I slip that in there, that's going to hold that tubifor in there. All it acts is just a spacer so this valve guide can't drop on through. So I believe we should be ready to come over here and start making the first cut. I want to put a little bit of lubrication on that pilot where it fits into the guide, because that is pretty close fit on that portion. Let's see if I can cut that out of there. I don't know if you can hear the machine trying to chatter just a little bit. That's because of the excessive clearance between the guide and the block itself. I have to really work with that to keep that at a minimum. Pay real close attention to my feeds and speeds. As we get close down here to being to the bottom of that valve seat as we're cutting, you'll be able to hear as it breaks through the bottom edge, and that's where I'll stop. Okay, we're very close. There. I could hear just a little tiny crunch as that went through on this inside edge, this direction. You should be able to see where there's some little pieces missing. That's where the cutter kind of went through the bottom edge and it chipped away. And that's what I could hear and knew it was time to stop. So now I'll pull that valve guide back up out of there. Just like that. We'll move over to the next hole. And let's do the same thing again. And again, you could hear that as it came through. You see these dark spots here, that's where it cut through the bottom of the seat, but I did not cut into the block itself. If I'd have cut into the block itself, those areas would be shiny, just like the seat material is. So I stopped at a good spot.
Okay, so we thought we'd maybe try to throw in a little bit of history or you know, some additional information on this, since it is kind of a, I mean, we're not Ford guys, but it's a legendary engine in the hot rod community.
Yeah.
I mean, by the time you got started in what, late 70s?
Yeah, by the time I started in this industry in the late 70s, these things were gone. Very seldom ever saw one of them. They were worn out in the scrapyard. But then as years went by and people started resurrecting the things for their hot rods, I've actually worked on more of these in the last 10 years than I ever worked on in the first 10 years of being in this business.
Despite being closer to when they were you know, 20 years out from, or 30 years out from the last ones that were made to now being, what, 70 years out from the last ones made? I mean, these things are getting pretty old. But they're kind of a unique engine. When they first came about in the early 30s, I think we were reading that what was kind of unique about this was that it was the first mass-produced V8 that was cast in one piece. There was a Cadillac V8 that I think was more considered the first mass-produced V8, but it was super expensive to build because it was a two-piece block essentially. It had the crankcase as one piece and then the cylinders, and it was still a flathead. It still had the valves in that assembly, I think. And we're just kind of spitballing stuff here, but people can comment about everything we say wrong.
Well, that's it. If it gets you excited, kind of like it did us, go out there and start doing a little bit of research, because that's what sparked us to try to find out a little bit more about these things.
But part of its success was being an affordable V8. But there's some weird things about it still. One of the things that I think you already commented on earlier in this video is the fact that the cylinders are offset from the crankshaft centerline. And we're still a little bit confused about that, because it looks like that number changed over the years. This is a later block, but either way, this cylinder is shifted up, or this bank of cylinders is shifted up that direction from the center line. This bank of cylinders is shifted that direction from the center line. And the idea there, actually what it does, we'll have to throw up a little graphic of that D-Sax engine or whatever, but it gets the crankshaft a little bit further over that, I don't know, direct line from the connecting rod.
center line of the piston down through the rod to the center of the crank, the crank is already a little bit past
that center line on the power stroke. So instead of kind of fighting itself, it already has some leverage to, push down through.
And the big thing was less pressure on the cylinder wall.
Yeah. Kind of just more efficiency overall, I think, with it.
Yeah.
But the other weird thing about that you commented on is that also made it so they had to change the angle of the valves.
Yeah.
And that's another thing that we can't quite fully wrap our heads around. But if you look at the way the valves are angled relative to the center line of the cylinder, on this side, let's see, which way is it? Now I'm over here and I can't think about it.
Let me switch sides with
spots. Well, relative to the deck surface, these ones are angled over that direction a little bit more than these are.
Yeah.
But that all has to do with the way that things are offset. And I assume maybe there will be somebody who grinds cams watch this video.
Yeah.
But that would affect the lobe spacing.
Yeah, I think anybody that grinds cams probably knows more about that, but I think there's probably going to be something funny with the camshaft too in conjunction with what's been done here.
Yeah, because it's kind of weird. It's just kind of weird that they're at different angles, and that's why the valve seats look different, because again, the top of the valve seat is tilted over a little bit more.
You would think normally one bank would be identical to the other bank, but with all these little changes, the valve angles and the way the valves sit in the top of the block are not the same from side to side.
And maybe it's just me as a machinist or kind of analytical type thinking, but I don't like stuff that's not symmetrical.
Right.
It just kind of starts to mess with your head, and I think that's where I first noticed is, you can see that this top row of head bolts is further down than on this side, and it's just like, that doesn't look right.
And I had never paid that much attention to one before. I had remembered the valve seats did not match from side to side, but as I started looking at this more with the intention of, hey, we need to do some explaining on this, all of a sudden I realized, wow, there's a big difference here in where the head bolts are.
Yeah. Speaking of head bolts, don't you love how back in the day they had 50,000 head bolts for their whole 7-to-1 compression, or whatever this one came out to?
But didn't you read somewhere that the factory's tolerance on this was 5/1000ths?
Yeah, they did. There is a video, and it says their spec on flatness for the deck here was 5/1000ths.
Cylinder blocks coming from the foundry go to the big milling machines, and this one, the surface of the cylinder bank is milled. First a rough cut and then a finish cut, and the surface must be true flat within a limit of 5/1000ths of an inch.
But think about that. You have this little thin flathead on there with lots of bolts, so it probably would pull that head in,
flex it and make it
flex it
seal up
enough to make it seal, even if there was 5/1000ths of imperfection there.
I'd hope we're closer to
Yeah,
5/10ths on this, but
and this block was closer than that when I started on it, because it was a pretty nice block. But just think about today's gaskets, our multi-layer gaskets, and how perfect the finish has to be to get them to seal compared to what this was with those composition type gaskets.
We also want today's engines to go 300,000 miles. And what do you suppose these were designed, what were they hoping for?
I don't know, but 100,000 miles on these was a lot of miles.
Yeah.
And probably before it ever got to 100,000 miles, it had already had several valve jobs done on it.
Right. Lots of work done on it
Yeah.
in that time. There is an interesting video on YouTube that we'll have a link to that people can go check out. But it kind of has their manufacturing tolerances listed. They show kind of the manufacturing process, and it's from the earlier Flathead V8s in the 30s. But I know one thing that caught my eye because we were just balancing that Chrysler out there the other day. It said they balanced the assembly to within 0.3 ounce inch, and I was just doing a little bit of looking on that one where we were at. We were balancing to within, we ended up actually under half a gram at about 3.5 inch radius. And when it's all said and done, 0.3 ounce inch would be 2 grams at that same radius.
Okay.
So it's still I mean, they had a pretty tight tolerance.
Yeah, that was pretty close balancing on that.
Now, the question is, were they actually hitting the tolerances that they were talking about in this seemingly, I don't know if it's a promotional film or what. It sounds like a promotional film for the cars. Who knows if they were actually hitting those tolerances, but it's kind of funny to hear this kind of absurd to us tolerance on the deck surface, and then you have what seems to be a pretty, I mean, decent tolerance for a stock engine on the balance. Yeah. But it's kind of interesting. I mean, these things, like you said, we don't see a lot of them. I've seen 2 in the 5 or so years that I've been working here. I don't remember what that last one we did, what year range it was from. It
would have been the same thing. So at this point, we've gone through all 8 seats here with this tool and have removed about half the material of the valve seat itself. So now I'm going to adjust this out just shy of the actual outside dimension of the seat. Sometimes you have to kind of guess what that might be, but I was lucky on this engine. My process software tells me that the outside diameter of these valve seats is supposed to be, the intake is 1.630, the exhaust 1.639. I think I'll adjust this out to about 1.610. I think will be a good place. Give us some room there so we don't accidentally get into the block itself, but at the same time cut it thin enough so I can easily pop that seat out of there. So if you give me just a couple minutes here to get this adjusted. And I don't know if you noticed it or not, but as I were cutting these, the exhaust seat material is definitely different than the intake seat material. You can see when I'm cutting, the chips come out a little bit different between the two. I don't know exactly what the difference is in the material, other than I can tell you there is a difference. And we already have a guide in this hole down here, so this time through I'm going to work the opposite direction. No rhyme or reason for that other than that's just the way I'm doing it. I want to come back up out of there and check my work here just a little bit. I want to take a look at this and make sure that I am leaving just a little shell of the old valve seat. I want to make sure I'm not getting out into the block. Although it wouldn't make, as long as I didn't go excessive, it wouldn't make a big difference because we're going to go with oversized seats anyway. But the way my luck goes, I would be actually bigger than the oversized if something was to go wrong on me here. There we are. Now if things went right, let's see if we can get that valve seat out of there, or what's left of it. Look at that, just a shell of the old valve seat. And you see down in here the bore, I did not even touch that with my cutter. So if a guy wanted to, and I was to order the factory size valve seat, I could just clean that up, put another one in. But I think we want to open that up, put an oversized seat in so that we know it's going to fit properly. Now watch when I do this one and see if you can tell the cuttings coming out of there are a little bit different material. Look at that. Darn near jumped out at us. It's funny, once you crack one of those, they just kind of curl up and come right out. And again, did not touch with the tool. So let's just go through, maybe cut all of those, and then come back and peel them out of there one at a time. You can mate up all kinds of different transmissions to it, because I think the guy that was doing the last one was mating up maybe like a, oh, I'm not a Ford guy, maybe like a C4 transmission or something like that. Anyway, mating up a modern, or at least something out of the 1970s as far as an automatic transmission to that engine.
Yeah, so maybe a little more options there.
Yeah.
Because I did see another video of somebody that was building one on YouTube, and they were talking about how you have to put the flywheel and the the clutch or you know, whatever in before you put the oil pan on.
Yeah.
Because
it's
of the way it's in there.
Yeah, it's all up inside that bell housing.
Because the oil pan becomes part of the bell housing too, the way that it's designed.
Yes.
So that's kind of different from this.
Valve chamber cover plate with manifold integral and cylinder heads are soon assembled. Next comes the oil pan. Then the transmission and the clutch are attached.
But yeah, so I guess I was going to ask you this. There's no core plugs along the side. These are the exhaust ports.
That's the exhaust ports.
So did they use that to get the cast, you know, because the core plugs are not actually freeze plugs like people think. It's actually for when they're casting it to basically wash all the sand back out, right?
I'm guessing that this had enough openings on the deck surface here, because there are
big enough and enough openings.
A lot of big openings here that they were able to get the sand out there, and
plus
also on
huge.
the front where the water pumps go on. See, that's another thing. There are 2 water pumps on these, one for each bank here, and and holes down here. Lots of places they could get the sand back out them when they was working on them. And you know, that's another thing. The way these are designed, the intake is not so bad as far as the flow coming in. But my gosh, this exhaust, you know, once it goes through the valve there, has to come all the way down through the water jacket and out this hole on the underside here. I mean, I can hardly get my finger up in there.
Yeah. They have a pretty bizarre situation as far as airflow is going on. Because like you said, I mean, going down through like this for the intake is not crazy, other than as the piston is pulling down, it does still have to make a pretty aggressive 90-degree turn, you know, well, 180-degree turn into the cylinder. And the exhaust.
And the hot rodders, they would cut this area out. If you ever heard them talk about relieving a block, that's what they was doing, is cutting this area out so the air could make the bend into the cylinder a little bit easier.
Yeah. Well, and then on the way back out, you know, the air has to come up like this into the exhaust, and then like you said, it's a pretty gnarly, weird curve there.
Yeah.
And the intake and exhaust are kind of fighting each other.
Well, that's it. During your overlap period, you got air coming in here, trying to get in the cylinder. At the same time, it's going out the exhaust there next to it.
And
kind of two-way traffic.
Half the valve shrouded by the head.
Yeah.
And talking about relieving this here, it's kind of a toss-up because, like we were talking about on the heads, you could deck the head a bunch to decrease the chamber size, but then you get to a point where your valves can't open enough.
Yeah.
So
if you took that much off, then you'd have to cut reliefs in the head for the valve to go back in, and just defeated.
You're just
everything
fighting.
just done.
You're fighting back and forth between airflow, trying to get the valves open, and dropping your compression ratio because there's only so much room to work with there. But I mean, still, they were around for what, 20 years?
Yeah, from
32 to 53. Is that right? 54.
So 20 plus years of production of this, not this exact block, but of,
Pretty similar.
yeah, pretty similar, just like any engine. You know, small block Chevy from 55 to what, 2000 and something, but there were a lot of different variations of it along the way. Little things got changed, same way like with this.
So, what other kind of oddball things are there on these that you've seen, or that are a little bit different than, as far as the oil filter and?
Well, they're bypass oil filter, and there is a way of making some changes on this, and you can turn it into a full flow filtering system on it.
Explain that for people who have no idea what you're
Well,
talking
a
about.
trickle filter, they just bring a little trickle of oil out of the engine, goes through a cartridge oil filter, and just drains back into the pan. So the oil going through the engine itself is not fully filtered, but there is a filter that will take some of the garbage out of the oil so it doesn't just all stay inside the engine. A full flow pushes all of the oil through the filter before it goes into the engine, so your oil is always completely filtered before it goes to any of the critical parts inside the engine. This kind of weird things back here on the back. I don't know if you can see that. There's a gear on the back of the camshaft here that in turn runs an idler gear that sits in this position here, and then the oil pump comes up in from the bottom and runs against that gear. So there's one extra gear back here to make the oil pump work.
I think you talked about the lifter or the valve guide design, I assume.
Right.
And early they were a two-piece valve guide.
Yeah, the early ones were a two-piece valve guide, and they had the end of the valve was mushroomed out to where that's why they had a two-piece guide, is you had to fit it around the valve.
Right.
And then put your spring and keepers in.
Which we showed on a Model A video that we did. We talked about that a lot.
Split valve guides are made in perfect half circles, making them interchangeable. Here the halves are being lapped and gauged to bring them in half circles. We move to the motors building again and to the assembly line. Assembly of parts into the block begins here. Valves are ground and are properly seated.
I personally think these things are kind of tough to work on as far as getting in here, put the valves in and out, and of course the machine work doesn't, what you have to do on the valves here does not lend itself well to our modern machines. But when I first started out, you'd get the old timers come in, probably guys my age now, but they'd come in and just rant and rave and go on and on about the good old days working on these old flatheads. And I'm looking at these guys like, dude, what is wrong with you? I think they're really hard to work on compared to overhead valve, Ford, V8, Chrysler, whatever.
Yeah.
And of course nowadays with all the overhead cam stuff, those are a lot tougher than what these are. But in that time period, the old guys that started their career working on these just thought they was wonderful.
I think overall people don't like change.
That's right. They don't like
And
change. The ones that started out working on these did not like the change when the valves ended up in the head itself and they had to deal with rocker arms and push rods. And
well, I still think of that poor kid down at Julesburg at the drag strip that when you saw his little Honda with a 4-cylinder sitting sideways in the front and he was all excited to show you. And you were just like, that's just wrong, and walked away.
Well, it was wrong. Drag racers are supposed to have the engine sitting front to back in the car, rear wheel drive. He had everything wrong. He had a 4-cylinder motor. He didn't have a V8.
Yeah.
Had it sitting sideways and front wheel drive.
But to him, you sounded just like these guys who wanted to work on
I'm
these.
sure I did.
So I don't know. I honestly think, I mean, this one for this customer, we were just doing machine work on it. But maybe we should try to find one of these and do a deep dive on it.
Yeah.
And do a series and figure out if we can understand it a little bit more than we do right now. Because this was kind of an afterthought of, let's just talk about some of these oddball things.
Because the only reason I even thought about, hey, we ought to do a little video on this is because one of the commenters said, hey, I'm getting ready to do an 8N Ford tractor.
Yeah.
Do you ever do any of those? And this is half of this is about the same as an 8N Ford tractor.
Yeah. And either way, there's probably not a lot of these that have been done on a Surrey valve seat machine.
No.
So hopefully it's about the nicest one that's ever come out. It's the nicest that'll ever come out of our shop at this point. You still got to hone it and finish up some other little things.
Yeah,
but
I need to hone it for the customer, fit his pistons. He wants me to put the cam bearings in. And we've got the heads. We'll surface those for him.
So anyway, kind of interesting stuff. I think maybe people can drop comments of stuff that they know about it that we didn't know, because there's probably a lot of those old timers watching our videos based on our demographics that I see sometimes. It's funny watching the demographic on our videos change from engine to engine, because sometimes we'll post an engine and you see and it's all 60-plus-year-olds watching it, and then the next engine it's more down in my age range, 20 to 40.
Yeah.
So, but anywho.
Another one. Our last seat. So now I'll have to come back with the seat pocket cutter, and we'll enlarge those from, I think the book said roughly 1.630, 1.640 to 1.687. So we're going to go about 40 to 50 thousandths larger depending on which hole it is here. And then our new valve seat should fit with the proper press fit. Where I pulled these seats out, there's quite a little carbon buildup under them and rust. I think I'm going to go ahead and wire wheel that clean before I cut the counterbore. That stuff's kind of hard on the tooling. Clean them up just a little bit, I think things will work better. So I have my seat pocket cutter installed in the machine, and I have my new valve seats here. My new valve seats I'm using are exactly the same depth as what the original ones were. So I'm going to go in with my pocket cutter here, and I will cut down until I just touch off on the bottom of the old original seat pocket, and that should give me the exact proper depth for those to be in there. Again, I'm going to put just a little bit of lubrication on the pilot. And a little bit of coolant for while it is cutting. Okay, I felt it hit bottom there. Touched off on the bottom. Let's clean that up, see what it looks like. Yeah, I'm very happy with the way that looks. Let's go ahead and go through and do all the others.
So not on the last one that you just cut, but the one right before that, the second one you did, it sounded like it had a lot of chatter, and then you did something up on the panel that actually changed the noise that was going on, and some people have commented about whether or not the SerDes is actually modulating its speed. Is that something that it's doing? Or?
I punched the button to modulate the speed.
Okay. So there are times when you cut it where you do have to modulate it,
Yeah.
but there are other times that you try to do it consistent.
If you can vary the speed up and down, it'll break the harmonics and quit chattering.
Okay.
When I was cutting, making those cuts to get the seat out of there, I had it doing that the whole time. Normally when I do this, I run it, well normally I don't do this on this machine. I still like that machine better.
Yeah.
But I normally run it just a steady speed, but that thing was
It
working at
sounded-
giving me trouble.
Yeah, no, it sounded chattery for sure. That's why I was...
And I hit the button real quick. I also reset the 0 on here so I could see how close I was getting to the bottom. But this machine, it won't let you reset when it's running. You have to stop and reset 0 and then start it again. So I hit the stop real quick, I reset and start again. Trying to do it before it stopped.
Right.
So yes, that one there, I'm just running steady speed. If I hit the button one more time, it varies the speed up and down. That sometimes helps break chatter if you're having problems. But normally that's not an issue, so I'm going to try to do it without.
So that time you knew you were close enough to the bottom when it started chattering like that.
Yeah,
that you were like, I didn't need to change it.
No, I didn't want to change it at that point because it would make it hard for me to hear and tell when I really was at the bottom. I was so close to being there that I thought it was better just keep going than to try to back out of it and change what I was doing and possibly miss the bottom.
So is it better to cut them at a consistent speed, or is there a reason that you like to do that over variable speed?
Well, like I was saying, I normally do valve seats on the other machine that does not have that feature, So I guess I just haven't gotten used to using the variation when I'm cutting seat pockets like this. And a lot of times, you know, what works on this one doesn't always work on the one next to it. Sometimes you have to kind of vary what you're doing on the fly to get the results you're looking for. But for instance there, I just touched off. I want to zero my DRO over here, so I have to stop the spindle, zero, start it again. Now I'm zero on my DRO, which it isn't anything other than just an indicator for me on this one as to where we're at. And right there I'm starting to get a little, I can feel the vibration in it. Sometimes it's a matter of feeding a little faster. Sometimes it's changing the speed. Sometimes it's adding a little more coolant. That one I ran just a little bit slower, and it seemed like I maybe had a little less chatter. Good. Okay, Josh says we're back on the air here again. So let's continue on with installing seats. So we've got those all cut. They came out real nice. We touched off on the bottom on each one, did not make them any deeper than they were, so they should fit nice. We want to blow each one out. Make sure I do not have any kind of debris underneath those to keep them from seating down where they need to be. Normally, most engine, this guide would be pressed into the block itself rather than being able to come out. So I'm just going to use my expanding pilot on the inside of this. And let's start on this end up here. I'm going to drop that down in. Again, my 2x4 under there keeps it from falling clear through. There's an adapter sleeve that goes on. My seat goes in there with the bevel side down. And I have my trusty driver to drive that in. And I have to tell you people, we almost never ever do any abusive driving or anything like this when we have the head mounted on the SERDI. But this block is so cumbersome to take on and off here. I'm going to break my rule, and I'm going to go ahead and drive the seats in with it on the machine. This is all solid enough, big enough mass. I don't think we're going to create any issues for the machine itself. So I have my seat in place, a few sharp whacks with the hammer, and always before I get completely to the bottom, I blow a little bit of air underneath the valve seat to make sure they're clean. And you can hear I've hit bottom. There we are, bottom. You can definitely hear when that hits bottom. This is one of those times when it would have been nice to have had some liquid nitrogen here to freeze the seats and maybe drop them in there a little bit easier, especially since we're working on the machine itself here. But again, to go get that, it's a 30-mile round trip for us. The expense, the time, unless we have a really good reason to have to use that, it's just not worth it.
So what do you say to the people who tell you to dress your driver?
I tell the people that if I was to dress that about the second job, it would look just like that again. And this is a real soft material. It does not fly off like if this was a harder, like a regular chisel or punch are made out of harder material. And I've had those when they looked like this, or even long before they looked like that, pieces would come flying off. But this one, if you watch when I'm using this, you'll see pieces of this kind of just flake and fall off. And anytime one of these bigger chunks has come off, it literally just falls off. It does not go flying at the speed of a bullet like some chisels do. So I just don't worry about that. It's to the point now. Yeah, I could go ahead and dress that, but it wouldn't be very long and it'll look just like that all over. I do appreciate their concern for my well-being, but this is just not a place that is a worry to us. And again, my favorite hammer. I saw in the last video somebody thought they should start a GoFundMe to get a new hammer handle, but it just wouldn't be the same with a new hammer handle. There's bottom. You definitely feel that. Okay, we have all our seats in, and the only thing I don't like on this side, remember when we started out we was talking about how on this side of the block the seats actually sit a little bit below the deck surface. If you can see that top edge there, and because of the way the cylinders are offset and the geometry of everything, on the side we're working on now, when I had surfaced it, it had actually cut across the top edge of that seat. And I may have to put this back up on the, I'll try to do it with a file, see if I can go across there and clean that up. But I may have to put this back up on the machine and just ever so lightly touch off on that to clean this edge up just a little bit. I'm not liking the way that looks right now. It's not hurting anything, but it hurts the way I feel about it. So now we're ready to actually cut the seat surface on there so the valves will seal. Once again, that requires the use of our 3-angle form tool here. And I left this purposely set up just like it was when I did the other bank. so that when I cut this side, it will match the first side. So let me get this all set up in machine, and we'll come over and see if we can get those done. I laid a piece of electrical tape along this side of the block and a piece over on this side in an effort to hold my file above the surface out here. And I wanted to see if I could just file that edge off by hand rather than having to put this back up in the surfacing machine. And I can make a improvement on that. I think this is one of those deals, if I had a brand new file, I could probably work with that a little bit and get those down where I would like without having to put this back on the surfacer and surface the entire deck. So let's go ahead and finish the valve seats, see what they look like. I might run into town and get me a brand new file that's nice and sharp and attempt to work this by hand. I think I can achieve the results I want that way rather than having to set this all back up in the actual surfacer and going to the trouble to do that, and in the process I'd have to take you know, a thousandths or two off the deck anyway. I don't want to do that. Well, hopefully we're to the home stretch now. I've got my form tool installed here. It was already set up when I did the opposite side of this block. I have a valve guide down in the end cylinder here. I guess this would work better if I turn some air on. There, now things will float. And we're going to see if we can put the seat angle on those new seats we installed. They're pretty simple, not much to them. 45-degree angle, 60 thousandths wide, narrowed up with a 30 from the top, 60 from the bottom. But this, everything being brand new, I really won't be, in essence, narrowing the seat up. I will just be cutting until I can see a sliver of the 30 and a sliver of the 60 on the bottom. So let me get this centered properly. And this is going to be the hardest part for us because again, that guide where it goes in the block does not fit all that solid, and I've been fighting chatter all the way through on this process. So I'm going to use my variation on the speed there. Let's come down and see what happens. You can see I have my 60 down below. Oh, there it's starting to try to chatter just a little. Change my speed a little, see if that helps. Okay, if you look really, really close, and you will have to look close. I hope that's in a good spot for the camera. There is my 45-degree seat area, and at that top edge, if you look very closely, you can see the 30 just breaks the edge, and same way down below, the 60 just breaks the edge there. Let's put one of my valves in there with some color on it. See what things look like. So there we have the face and the seat. Uh-oh, hits my wood down below. Let me move over a little if I can. There we go. And again, I'm not lapping the valve. We almost never actually lap valves. But if I spin that as if I were lapping the valve, it rubs the color off so I can see where my seat contacts the valve. And I like where that's at. I haven't had to change much on that edge of the seat. Didn't have to do a lot of cutting other than just enough to get my 60 down below and edge of 30 on top. I'm not clear to the outside edge. I've still got some room to go there. Very happy with the way that turned out. And it sounded like it was trying to chatter just a little bit, but I don't think it actually did. So let's move on to the next one. See if we can get these done. Again, like I said, we're on the home stretch. There, tried an old trick Nicholas taught me on that. Turn the speed up all the way on the machine and then start it, and as the speed is coming up, and make the last cut, and it takes out the chatter sometimes. But I'm not happy. I want to go just a little bit more on that one. That one came out nice. Now on this last one, again, I'm going to have to move my block down that acts as a stop.
So do you have a patent on that piece of wood, or?
I'm going to get one.
Oh, okay.
Yeah. I think that's tomorrow morning, first thing. I'm going to get a hold of a patent attorney. If anybody out there knows a good one, you might pass that information along to me.
In the comments below.
In the comments below, let me know the name of a good patent attorney that could help me get a patent on a 2x4.
And it better not be Saul Goodman, okay? We don't want anything like that. This is a legit business.
And there we have it. I would say we have a finished valve job on this engine. All of those seats came out real nice. I have them all to the same depth. I have 1.5 millimeter, 60 thousandths wide seat area at 45 degrees, a tiny sliver of 60 degree from the bottom into the port, brakes at the top with the 30 degree. Looks very similar to what that engine was when it was brand new from the factory. As we talked about there before a little bit, I'm going to come back with a nice file, lay some tape on here, a nice file, and just break this edge here that we have just a little bit. Probably not going to make any difference on the way the engine runs, but it'll make me feel better with the way it will look when I get done with that. So I think we're probably ready to take this block off here, and I still need to finish honing the cylinders. Like I say, I hadn't intended on doing any video on this engine at all until that customer left a comment about wondering what a valve job would look like on an 8N Ford, which is the 4-cylinder tractor version of this same style of block. As we said before, a lot of the parts interchange, same design on the valves and guides. So there's a lot of those still out there in the farming community. And of course, this engine here is somebody just doing a restoration on an old car, and I think they have a very nice block here to work with. It should make a nice engine when they get done. So I think that kind of wraps things up. Hopefully that gave you guys an idea of what this style of engine looks like, with the style of valve guides these use, and this being a full L-head design as opposed to the F-head design that we did a video on earlier off of that Jeep engine, where the exhaust valve is in the block and the intake valve is in the head. But this engine here, all the valves are in the block. So anyway, that wraps it up. Thanks for watching. Be sure to like and follow, and we appreciate you guys. See you later.